and welcome to our Build a Battery lab. For this lab, you will be following through with me, and we're going to be making some notes that go along with the procedure provided. We're doing this for a couple of reasons. So this is a lab with a lot of little steps. No step is inherently difficult, but it's helpful for you to have a visual prior to actually walking in the lab and doing the lab. It helps you work efficiently. So what we're going to be doing in this lab, we're going to be doing an investigation or a lab to figure out what combinations of metals and their aqueous solutions, aqueous meaning liquid, produce the highest voltage. We're going to build a data table of the voltage of different half cells versus zinc electrode. We're going to be using zinc as our standard. And we're going to record those findings in a data table. That's part one. Then we're going to use what we learned in part one to predict some voltage potentials of different chemical batteries in part two. For the procedure, you'll notice there's a written step and then there's some blank space. In that blank space, you are going to be writing teacher notes. I'm going to do this first box with you. After that, it is your responsibility to fill in the box as I'm doing the procedure. Now, step one, we're going to prepare our standards. Remembering what I said above is zinc is our standard. So we're going to prepare our zinc half cells. We need 5 total. Because we're running a lot of different reactions, and I am doing this for the sake of space, you will not be doing this. We're going to be doing these reactions in something called a well plate. We are going to fill the first row of our well plate, not the full row, just 5 wells, around half full. Half full is about 1.5 milliliter. That's for your teacher's purposes. For your purposes, half full. And we're going to be filling them full of zinc nitrate, which is ZnNO3 2. So what I'm going to do after I've done my standard safety precautions, like make sure I have a clean workspace, I've put my goggles on, I've tied my hair back, I'm going to fill these wells with a liquid solution containing zinc ions. This lab has a lot of chemicals. So I'm going to move my camera so you can get a visual of the tray. Some of these chemicals are solids, some of these chemicals are liquids. Anything that says nitrate is going to be a liquid solution. So I'm just going to look at my different bottles. Lead nitrate, not what I need. Nope. Until I find my solution. I need zinc nitrate. And I'm going to fill the first 5 wells of my tray half full with zinc nitrate. So I take the lid off. Keep the lids handy. All of them are similar. 1, 2, 3, 4. That's a little more than half. And see what I did? I just took some out and put in a different well. It's fine. These are all the same chemical. 5. Now, I know this is a clear liquid and you can't really tell, but if you were to look at this from the side, each well is about 1/2 filled with a clear liquid. That clear liquid being zinc nitrate. So this is step 1. Some teacher notes you can make for step 1. I've already made a few because I was writing as we went. I filled 5 wells in row 1, which means I went across. And I filled them each up about half full with the chemical zinc nitrate. Zinc nitrate was a liquid and it was clear. This would be an example of teacher notes for Step 1, I've summarized the procedure. I've indicated the chemical, and I also put some things down here that will help me know when I do this lab for real that I'm looking for a liquid and it's clear. For these boxes, from here on out, you will fill those out on your own, and your teacher will check those off as evidence that you have done your pre-lab. All right, step 2, we need to prepare our zinc metals. I am going to sandpaper 5 samples of zinc. Each sample of zinc is about 25 millimeters by 3 millimeters. That's a note for your teachers to help us remember how to properly prep this lab. All you need to do is look for the right chemical. So zinc is a solid. It's a solid piece of metal, so it's flimsy, flexible, shiny, and silver. Now, in order to prepare this metal for the lab, I need to sandpaper off the outside layer. That outside layer contains zinc that has reacted with the air. And I don't want reacted zinc, I want fresh zinc. You will have real sandpaper. Ours hasn't come in yet. I'm using paper towel. You're gonna use sandpaper, but it should be this color. So I've sandpapered off the outside layer. And I'm gonna do that 5 times. Now it's okay, these are not all perfectly uniform pieces because they were cut by your teachers, but for each piece I'm gonna sandpaper. For the sake of time, we'll just pretend I very carefully sandpapered all 5. That's step 2. If you need to pause this video and give yourself time to write in this box, you may go ahead and do so. Now, zinc is our standard, so that's why we need 5 pieces of zinc. We are comparing zinc to 4 different metals, to 5 different metals. Now, I need to prepare my other metals. So I need to get 1 piece of copper, sandpaper that, sandpapering everything. Clean, clean, clean. Same reason, we're removing that oxidized layer or that layer of metal that has reacted with the air. I need to receive my iron. Now, iron looks different. The kit they sent us is a whole iron nail. That's fine. This iron nail has actually already been used in a demonstration video for this course. You can kind of see it's got some coloring on it. You want to just scrub that outside layer off, okay? Scrub, scrub, scrub. I need lead. Now, we did learn about lead last unit. This is solid lead. So it is okay for us to be handling this sample as long as we follow reasonable safety precautions. We're not going to ingest it. We're not going to eat it. And we're going to clean our hands when we're done. So I've cleaned my lead, my magnesium, and all of these samples, I guess I should have showed you all the beakers, are in beakers that are labeled. Sandpaper. And then the last one is silver. Now, for reasons that hopefully you already know, this metal is going to be controlled by your teacher. So when it is time to get the silver, please go to your teacher and get your piece of silver from her. And then sandpaper it as such. Okay, that's step 3. So far on this page, I have filled my standards. 5 cells in row 1. I've cleaned off my zinc strips, and I have prepared my other metals. Now, you're going to turn your page. I'm going to slide my page. We need to prepare our half cells. I am going to fill row 2 using the same filling pattern that I used for row 1. And I'm going to fill them half full. So in row 2, you will not put this on your paper, but I am. The first well needs to get copper nitrate. Copper nitrate is a blue liquid. And I'm going to fill that well half full of blue liquid. Next to copper nitrate, I'm going to put lead nitrate. Next to lead nitrate, I'm going to put iron nitrate. Careful with those clear liquids. You don't want to do, I almost did it, which is put it in a well I've already filled. Next to iron nitrate, I'm going to put zinc nitrate. It's not zinc. Wait, no, I'm not. Yes, I am. Wait a minute. That's a typo. Your paper will be right. Next to iron nitrate, I have copper nitrate, lead nitrate, iron nitrate. Your paper will read correctly and say magnesium nitrate. So magnesium nitrate is going to go next to lead nitrate. And in the final well, I'm going to put silver nitrate. Now, silver nitrate is a little bit of a different chemical. It's light reactive, so that would mean it would react if it was in the presence of light, so it comes in a brown bottle. Fifth well. Okay. So 5 wells, all filled with their different chemicals. And at this point in time, it's a good idea, stop and make sure you put all the lids back on. We do not need 6 different chemicals with their lids off at your station. Now, I need to move to step 5, and I'm gonna put my metals in their corresponding solution now. What I mean by corresponding solution, so all my pieces of zinc, which have been sandpapered and clean, are gonna go in a zinc ion well. So zinc goes with zinc, so I'm putting a piece of zinc in each of these 5. And then I need to follow my order from above. The first well that I put liquid in was copper nitrate, so I'm going to put my copper metal in the blue liquid. The second well was lead nitrate, so I'm going to put my lead nitrate in that well. The third well was iron nitrate, that's my nail. So usually I put the butt end in there so it stands up. The fourth well was magnesium nitrate, that's correct on your lab now. And in my fifth well, I'm going to put the silver with the silver nitrate. So that's step 5. I have placed all metals in liquid solutions that contain their metallic ion. Step 6, I need to create the salt bridge that will allow for ion flow between the 2 wells. I am running 5 different batteries, 1, 2, 3, 4, 5. So I'm going to prepare 5 salt bridges. I'm going to get an empty beaker, and I'm going to put 5 pieces of filter paper in there for now. This will get me enough to do part 1. It doesn't take much. I'm going to add some potassium nitrate to that filter paper. A few drops, just enough that it's soaked. 1 pipette filled all of those easily. And I am going to put a new filter paper in each well. So I'm going to handle these with tweezers because I just put chemical on them. And I'm going to go get it. You will have 2 pairs of tweezers in your drawer. All right. Now, each reaction needs its own bridge. You will not be doing your lab on your paper like I am for that reason. So each well gets its own bridge. Now I know this is a little ornery, but remember, you did just put a chemical on this. So we are going to use the tweezers. We're not going to use our hands. It's tempting. And I'm going to pull those metals around so they're kind of peeking out for my next step. Okay. That is step 6. So my batteries are now complete. I have a salt bridge, I have a solution that will be a cation solution, and I have another solution that will be my anion, or my anode solution. All right. Step 7. I need to actually read how much energy is flowing between these different cells. So what I've done is I have my LabQuest. So we haven't used these yet. These are lab computers that collect different data depending on what sort of data collection tool you have plugged in. So this LabQuest is the computer. The data tool is over to the side, and I will plug that in. It's just a standard port. There's 3 channels over here. It doesn't matter what you put it in. Put it in one that it fits on. As soon as you plug it in, it's going to start reading something. There's some flow and some current going through the air, going through the controllers. That's fine. It's also okay that this is jumping around. If it's reading nothing, let your teacher know. Sometimes these are finicky and we might have to help you fiddle fart with them. What it's reading is volts. So that uppercase V stands for volts. So I have got my voltometer, which we're using a LabQuest for. We are going to connect the black alligator clip. This is the alligator clip to the zinc sample. You're going to have to move these around 5 times. So I'm going to take the black alligator clip. It's okay if that rubber end's being a little bit of a pain. Mine is. And I'm going to connect it to my first zinc sample. And it's okay. You might need to kind of reposition it so it doesn't tug. Just do your best. There we go. The important thing is it's in the solution. So I've got my black on my zinc, and I am going to connect my red alligator clip to whatever's in my other well. So I am working vertically. If it pops out like mine just did, that's fine. Just put it back. And now I've got my red clip, and I'm going to connect that to my copper. And this is how I collect the data for my first cell. So when I have zinc and copper connected in a battery, my current battery is able to create 0.920 volts. This number is not the exact number you will get. So remember, I did my sandpapering with paper towel, which doesn't actually remove the outside layer. Your number will vary slightly. That's okay. It should. I'm just trying not to give you the real answer. That number is going to be the number that you record in your data table. So what I'm going to do is, another reason we don't do labs on our papers, I'm going to pull my data table now. And if I was really doing this lab, I would fill that in as the voltage for zinc versus copper. I would write down what appears on that screen, which is 0.926. It jumps around a little bit, that's okay. Take where it's at most of the time. For the purposes of this lab, I'm going to give you 3 different values that are made up to help us with going through some data calculations. So let's say I have connected these and I got the data point 0.0987 volts. And then I'm going to move to my next sample. The way you move to your next sample is you just move the alligator clips. So I'm going to take my red and put it on my next other. I'm going to take my black and put it on my next piece of zinc. And here, I've got a different number, which again is like 0.370 volts. Sure, put that there. And you're going to keep moving down the weld plate. Now, so far, neither of these numbers have been negative. If it doesn't give you a charge, it's an assumed positive, and I'm actually going to write that in there. But some of the welds you do, and I'm not going to show you all of them in this video, will give you a negative value. And I'm just going to put that there as a sample. All right, so where are we at? We did that, prepared the salt bridges. We've done number 7. I've connected the alligator clips, I've written down the voltages, and I've moved those clips down so that your data table is completely filled out. next thing you have to do is determine which is the anode and which is the cathode. Now, this is a little bit tricky. If your battery is producing a positive voltage, it means the clips are connected in the correct direction, which means that your zinc, which we use as your standard, is your cathode. So it doesn't matter what the value is. If the value is positive, zinc is your cathode. If the value is negative, that means zinc is your anode. Which means your other metal will fill in. So here, element X is my anode, and element Y is my anode. And then here it'd be switched. Since zinc was my anode, that means my element Z would be my cathode. Take some time, make some little notes to the side here to help you figure out how you're going to be doing that later. Whoopsie. I actually did that backwards. So what we're going to do, your paper will be correct. Positive voltage. When the voltometer reads a positive voltage, the electrode connected to the positive terminal, which is our red wire, is the cathode. So when the number is positive, your other metal is the cathode. When the metal number is negative, your other metal is the anode. So on your paper, those two terms will be switched because I misspoke and filled them in marker. But positive numbers means that zinc is your anode. Negative voltage values means that it's hooked up in reverse, which means zinc is your cathode. Now, for part 2. Using the same well plate, we are going to predict and determine the voltage produced by 7 different battery combinations. To predict the voltage difference, we're going to subtract the anode value from the cathode value using the data that we collected in part 1. Just like we had some sample data here, we're going to run some sample calculations there as well. So the first procedure in part 2 is actually doing some math. So I've got it, so now I can see both. This is my data collection for part 1. This is my data table for part 2, and I'm going to reread. To predict the voltage difference, I'm going to subtract the anode value from the cathode. So my equation is going to be most generally cathode minus anode. So my cathode here is XX. My value for XX is 0.987. My anode here is ZZ. ZZ had a value of negative 0.341. Now, hopefully you remember some math. A negative subtracting a negative, that cancels out, and that is positive. So anytime you have 2 negatives, what you're really doing is adding. So 0.987 plus 0.341. I should get a voltage of 1.328 volts. And we can do this for all of our table. Take your cathode, subtract your anode. My cathode here is X. Subtract that from my anode here is Y. Y had a value of 0.370. No double negative here, so I can just type that in as I see it. I get an answer of 0.617 volts. And you're going to predict the potential for 7 different cells that you have not built. Then you're going to build those cells and you're going to compare. How does my predicted potential look compared to what I actually get in lab? But procedure step 8 is just doing the math. Find your cathode value, it's indicated, which one's your cathode, and then subtract your anode value. If the anode value that you got in part 1 was negative, make sure that you have those 2 negatives equaling a positive. Okay. Part 9. We're actually going to run the reactions that we see in data table part 2. To set up the reactions for part 2, we're going to follow the same procedure as part 1. I'm going to place tested chemicals in adjacent cells. Adjacent just means next to. I'm going to fill each cell half full. Anytime I use a model or a metal, I'm going to polish it, which means I'm going to sandpaper. And then I'm going to add a salt paper, which is my filter paper, or a salt bridge. I'm always going to attach the black alligator clip to whatever is designated as the anode, and I'm going to attach the red alligator clip to whatever is designated as the cathode. Now, to help you keep track of that, you're going to map what you're doing down here. Now, in my well plate, I'm going to take the alligator clips off so I can move it around. I've already got the first 2 rows filled. Row 1, I filled the first 5 cells with zinc solution. And then I connected the zinc to the adjacent cell B. Here I put copper. Here I put lead, which is Pb. Here I put iron, which is Fe. Here I put magnesium, which is Mg. And here I put silver, which is Ag. I'm going to use my remaining wells to run some remaining solutions. Okay. So I would suggest having a lab partner on each page. The first solution that I need to run is magnesium versus copper. Magnesium is going to be my anode and copper is going to be my cathode. Now, to help me, I am going to put my cathodes and my anodes always in the same row. So, let's see. Because the black alligator clip was what we had in the first row, let's always connect the black one here. Okay, so what does it say? So the black alligator clip will always go with the anode. And then the red alligator clip will always go with the cathode. So my anode here is magnesium. So I'm going to put magnesium in this well. The cathode I'm testing against magnesium is copper. So I'm going to put copper in this well. And I'm going to connect these 2 with a salt bridge. Now I'm not going to show you all of these, but you can imagine the rest. Iron to copper. Iron to silver. And you will fill out these remaining wells. You will have to use this one up here, but you can still follow that same pattern. Let's put the anode, whoever is designated there, in the top row. And then we'll put the cathode, whoever is designated there, in the bottom row. Okay, So take some time, fill out your table with how you're going to fill these wells, and then I will show you just one example here. So my first well for part 2, we said we're putting all of the anodes here. I've already laid it out. I'm putting a magnesium solution here. The metal goes with its corresponding ionic solution. So I'm going to get magnesium nitrate. I'm going to fill that well half full. And then magnesium is being combined with copper. I'm going to get my copper nitrate. I'm going to fill that well half full. And then I'm going to get my metals. Every time you use a metal, you're going to polish it. So I'm going to get my sandpaper out, which again is a paper towel in mine. And then the metals go with their ions. So this is a piece of magnesium. Clean, clean, clean. Attaching it to a piece of copper. Clean, clean, clean. I set up the table so that my volts align. The black alligator clip going with the top row. Now, if you can't get it to stay, you can hold it in there. The red alligator clip going with the bottom row. And I just realized I did exactly what I also forgot the first time. I need a salt bridge. So I take a filter paper. I still had plenty of my potassium nitrate solution in there, so I'm just going to dip it in the liquid. Make a salt bridge. And then my lab quest should give me a reading. Whatever that reading is. This one is 1.67 before I knocked the electrodes around. And you're going to go ahead and put that in your data table next to measured volts. And you will use that to complete your lab. Good luck.